All right, we have content standard 50C right here, and we're going to be finding the magnitude of a vector. We have a couple of examples, and just because it's kind of a fast process. The idea of finding the magnitude is pretty much the same thing as the Pythagorean theorem. The idea is that this is your horizontal distance, this is your vertical distance, and you want to find your diagonal distance. That's all it's saying. So again, magnitude is y magnitude. So that's magnitude. So again, you're just gonna do this squared plus this squared equals this squared. So if we just do this in the same process, we're gonna take the square root of 2 squared plus negative 3 squared. And that's going to give us the square root of 4 plus 9, which is the square root of 13. You know what? Just for fun, I'm going to show you guys a little trick of finding square roots in your head. If you know the 2 square roots that 13 is near, so for example, 13 is between the square root of 9 and the square root of 16. You use this one, right? So you know it's going to be 3, and you go to create a little fraction. And to find out how far that fraction is, you 9 to 16, that's a distance of 7. And 9 to 13 is a distance of 4. 3 and 4/7. Now, they would not want that. They would like a decimal from you. 4 over 7 is roughly, I would say, like 0.6, right? Let's see. 4 divided by 7. 0.57. So then this is actually going to be like 3.57. And if we take the actual square root of our number, square root of 13, we will get, whoops, put 133. 3.6 is the actual square root. So pretty close. Pretty close. So this is something for yourself. Again, you guys have calculators, so it's not a huge thing that you need to worry about, but it was just a little trick that I was taught when I was younger. All right, next, example 2, 15i, 4j. So same thing, we're going to do 225 plus 16. I realize I skipped a bunch of steps. 15 squared is 225, 4 squared is 16. Sorry about that. We're going to go ahead and add these. 5 plus 6 is going to be 11, so that's going to be 231. Plus 10 is 241. Square root of 241 is probably 15.4, but let's just do that. Let's plug in our calculator, 241. 15.5, ooh, so close. 15.524. And this is all we're doing. And it doesn't matter if it's negative because, again, we're going to square it. So negative 12 squared is positive 144. Negative 8 squared is positive 64. 140 plus 60 is going to be 200 plus 4 is going to be 208. So we're going to get the square root of 208, which actually is a nicer number, but it's not quite 15. It's like 14.3 or something like that. 14.4, crap. Gosh, I'm so close. 14.422. You don't need the extra 2's, but, you know. Oh no, what happens if you have a singular number? Well, it's actually just easier for you. Because now what I'm doing is technically the square root of 8 squared plus 0 squared, which is the square root of 8 squared, which is the square root of 64, which is 8. Yes, I technically did more work here than I did on the other ones. But just to make sure we don't get confused in this in the future, right? It's just really nice. The answer is just what's there. Because the idea is we're only moving a horizontal distance with no vertical distance. The magnitude is the horizontal distance, if that makes sense, hopefully. And lastly, don't know why I gave this to myself. I have no idea what 37 squared is, but I guess I'm doing that. 16 squared is 256. 37 squared is a number that exists, and it's probably really big. It is 1369. That's a really cool number. Plus 1369. And then we're going to go ahead and add that to 256. And that's 1625, another cool looking number. It looks like it should be perfect. Honestly, this looks like the most perfect square number I've ever seen. but I highly doubt it's perfect square. So let's see. Square root of 1625, no it is not. God, no. It is 40.311. Even though it looks like it would be perfect. And that is how we find the magnitude of a vector. If you have any questions, please come to room E203.